Hi, this is a presentation of the first chapter in CCNA3, which is called Scaling Networks. And this is the first part of chapter 1. The first part is about LAN design, how we design networks from the beginning and also how we scale them afterwards, because typically that is what's going to happen, is that you have an existing network and you want to scale it either up and down. And there are some considerations when we are scaling networks and when we are building networks. And there is also a hierarchical design model that we will look into. So that is the first part. The second part is about the different devices and what we can choose from. But that is another video. So let's have a look at the design model. Of course, also what we have to consider and have to think about is that we would always like to be able to scale our networks. There might be some changes in the organization or in the company which require us to scale it either up and down. So the network should be able to scale. It should also be able to adapt to a converged network traffic. If we have different types of network traffic, it could be critical applications that has to be able to have network connections. We could have different business models, and there is we need to have some kind of centralized administrative control. These are all things that we would like to have when we design our networks. Yeah, and to help us and also to help us have an overview of our network, there is this hierarchical design model, which is designed or set up in 3 different layers. In the bottom, we have the access layer. This is where all our end devices are connected. For instance, the computers, but it could also be the video conference, it could be IP phones and such. So all the end devices where we have user interfaces will be connected to the access layer. In the distribution layers, this is where we connect the different, for instance, the different VLANs from the access layer. So this is where we interconnect all the different functionalities that we have on our access layer. Typically, this is where the VLANs are handled, but also where we could have different policies, for instance. Then on top of it, we have the core layer. This is where everything is built together. This is also where we typically have our connections to the outside world. So when you hear something about the core switch, this is the most important device in our network, because this is where everything comes together. Many small companies only have like a core layer and an access layer, because here we have the core and the distribution layer put into one, because in the core switch is where all the VLANs and policies and the internet connections are handled. But this is something that is helpful when we look at when we design our network, but also when we document our network. So when we want to design for scalability, we want to be able to our network to expand. We want also it to be easy to, for instance, to switch from both IP version 6 or 4 to 6. We would like to be able to have, for instance, layer 3 switches. We would like to have redundancy in our network. We would like to have something that if something goes down, we would like something else to take over. So all these things are consideration we have to have when we are designing our network. If we take the first, the redundancy, we like to have, for instance, so that if a line in our switch or a port in our switch goes down, we would like to have something else to take over. So within our switch setup, we'd like to create redundant paths. But we know, and we will look at that for in the next couple of chapters, that there is something called the spanning tree protocol that will help us have redundant paths in our switched environment. But this is what we want to do. So we want to have two different cables between two different switches, and if one of them goes down, the other one will take over. And of course, they will not be used at the same time, because that is where the problem occurs in a switched environment. But we like to have it to be able to take over. So when we create the big network, then we will make sure that between all our different switches and servers, we have redundant paths so that we can take over if something happens. We also like to have the failure domains described. A failure domain is an area of a network that is impacted if a critical device or a service experiences problems. So what happens is we don't want a single point of failure. So if something goes down at one place, that we could be able to bypass that one. Because if everything was connected into one central router, for instance, and this router goes down, well, then everything goes down. So we try to expand our network and try to avoid a single point of failure. That's difficult to do, but that's what we are trying to avoid. Increasing the bandwidth. Yeah, so this is where if we have, for instance, a connection between the switch and the server, and we don't have, for instance, a fiber optical interface or a gigabit interface or a 10 gigabit interface in our switch, and all traffic will go through one port because that's where the servers are. Well, then we can create something called an ether channel, is where we actually bundle two different cables or 4 different cables or 8 different cables so that they will actually work as one. And that could be a very good thing to do to avoid bottlenecks in our network. We would also, of course, be able to expand our on the access layer. For instance, if we create or if we build a larger building, or we expand so that we also want wireless connections everywhere, for instance, and we don't have that already, it should be easy to set up so that we will have like a wireless environment as well. This could incorporate, for instance, that we will work with power over Ethernet and such. If we have large, or if we grow and have to scale up, if we look at the routing part, we should be able to adjust that to a larger network. And for instance, if we are using OSPF, which is a routing protocol we will work with, well, then we can actually also segment it into smaller areas, because then we will have less routing traffic occur if we have a large network. So we will only have them within smaller areas, and then they will exchange information between the different areas. So scaling up is important when we choose the routing protocol. And there are different ways to fine-tune it. Also, EIGRP will be able to fine-tune. Yeah, and that was the first part. Thank you.